Okay, just a quick note, we had a problem like this in the homework, where you had, one of the conditions is that the limit as t goes to infinity, y of t equals 0, and you haven't seen that before, and some people are a little confused by it. So we've got to see how to deal with that. Now, I assume you can find the solution to the thing. You're going to get ours, well, I'm not going to read it to you. There it is. And there's your solution set, e to the 2t, e to the negative 2t. So your general solution is linear combination of e to the 2t and e to the negative 2t. So we apply this condition. Limit as t goes to infinity, y of t is going to be what? Well, it's going to be limit as t goes to infinity of this plus the limit as t goes to infinity of this. The limit of as t goes to infinity of this, c1 e to the 2t, is just c1 times the limit as t goes to infinity of e to the 2t. And if you're rusty on the rules for limits, they make a lot of common sense, but you might want to review those. And then, of course, we have the corresponding limit over here. Now, the point is that as t goes to infinity, e to the 2t approaches infinity. It grows without bound, unless the coefficient is 0. So if you have any coefficient except 0 here, you're going to get a function that grows without bound. No matter how small c1 is, this will grow beyond it, and as far beyond it as you might wish. This limit is infinite unless c1 equals 0, and that's how you deal with this. Now, this limit is 0 because e to the negative 2t, of course, approaches 0 because it's 1 over e to the 2t. So that your limit is going to be c2 e to the negative 2t. The other initial condition, you would have two initial conditions, and I think it's one, y of 0 equals 1 or something like that. But whatever the other initial condition is, then you can apply it to this function to evaluate c2. Okay, now the thing we really want to look at is non-homogeneous equation, second order equation with constant coefficients. We did this a couple of months ago, so people kind of remember it, but we want to make sure that it's right there. We have this. Now, solution set to the homogeneous equation, that's the equation we have 0 over here, is this, which means that any linear combination of these two functions plugged into the left-hand side is just going to give you 0. Well, to get a general solution that gives you this, you've got to find a solution that gives you this. So to find a solution that gives you the e to the 2t and cosine t, you think through it, you say, well, we're adding multiples of derivatives of whatever function it's going to be, and we have to get an e to the 2t out of that. How can that happen? Well, that can only happen if you've got an e to the 2t in your trial solution, okay? So my point here then is that non-homogeneous solutions should be a linear combination of e to the 2t, because if you don't have an e to the 2t in there, your derivative is not going to give you an e to the 2t. Sine t and cosine t. Now you obviously need a cosine t because you've got a 4y there. So you want to consider cosine of t. You also have derivatives of this thing, and if you're going to include a cosine t, your first derivative is going to give you a sine. So you'd better have a sine in your trial solution. If you don't have one, it's not going to work, and you can try it and see that it doesn't work. Okay, so what you do then is you let your particular solution be a linear combination of these. I don't want to use C1 and C2 because that's usually what we use with the fundamental set. So I'll use A, B, and C for my coefficients. So if yp, and that stands for particular solution, y particular, equals this, then what do the constants A, B, and C have to be? Well, it's pretty easy to find that. Okay, pretty easy to figure that out. We're going to plug this into the equation. Now before we do, we might as well do the derivatives, right? So we do the derivative of yp and the second derivative of yp. That's very straightforward. And then what you end up with Your y double prime, of course, is going to be this expression, which I've got right here. And your y prime is going to be this expression. Now we got 4y prime, so we'll have 4 times the expression for y prime, and then a 4y. So 4 times the expression for y has to equal e to the 2t cosine t. Okay. This means, well, how much e to the t do we have on the left-hand side? We know we got e to the 2t, e to the 2t, not e to the t. We got e to the 2t on the right-hand side. We've got 4a e to the 2t's here, and 8a e to the 2t's from this term, and 4a e to the 2t's here. So we can write that as e to the 2t times 4a plus 8a plus 4a. That's what we have on the left-hand side. Has to equal the e to the 2t on the right-hand side. So we have this equation, and we can easily then determine that a has to be 1/12. You can just add these up. You get 12a times e to the 2t equals e to the 2t. Divide by 12 e to the 2t, and you get that. Okay? With cosines, we have a negative cosine here, negative c times the cosine, and a 4b times the cosine, and a c times the cosine. 4c times the cosine. So we have negative c times the cosine, 4b times the cosine, and 4c times the cosine. And that has to add up to the cosine of t. We also have sine t terms, and you can see what they are. We have a negative b times the sine here. We have a negative 4c times the sine, which is here. We have a 4b times the sine, which is here. And that has to equal 0. This tells us that negative c plus 4b plus 4c equals 1. In other words, this coefficient has to be 1, so you have cosine t on both sides. And this coefficient has to be 0, so we get a 0 here. That's 2 simultaneous equations of 2 unknowns. And we simplify them, of course, adding the c's and adding the b terms here. We get these 2 equations, and we solve these equations. Very straightforward, but I did it in my head and screwed it up by some things are erased. Okay. You get b equals 4/25, and then you can plug that into the first equation, or you can plug it into the second, it wouldn't matter. And you're going to get c equals negative 3/25. And I think those are right. So our conclusion is that y double prime plus 4y prime plus 4y equals equal to our equation, same equation that we started with over here, has a general solution. That's what? A linear combination of your solution set to the homogeneous equation, which when you plug it into the equation should give you 0, plus our particular solution, 1/12 e to the 2t plus 4/25 sine t minus 3/25 cosine t. That's our a e to the 2t plus b sine t plus c cosine t for the solutions a, b, and c that we got when we plugged this particular solution into the equation. Now we want to check it and see if it works out, because that should convince you, or convince you that I still don't have the constants right. So let's see what you got.